Hey, beautiful people. My name is Ajay, and in this video, I would like to walk through a ML project I created on diabetics prediction. So I'll just give a basic, overview of what the data set is, and then probably I'll just go through the, step-by-step approach of how the data processing pre-processing is done, then what kind of ML models that I've been using, and how you could figure out or understand the likelihood of a person, whether a person is going to get diabetes or not. So yeah, so the first thing is I'll just show you the data set. So this is particularly for people uh, who are female candidates. So the data set is uh, contains only female candidates. So the dataset is taken from Kaggle. So the first uh, column is like the how much times the person has got pregnant. Then we have the glucose levels, the blood sugar levels, skin thickness, insulin levels, the body mass index, the diabetics pedigree functions. So what it tells you is the likelihood of a person getting diabetes based on the person's family history and age. So the value is between uh, 0 and 2.5. The higher the value, the higher the likeliness the person is going to get diabetes. And the age group and the outcome. So based on this, like 1 means the person is diabetic and 0 means he is not. So we are going to use this data set. We're going to train the model, and then we could use custom inputs to figure out like if a person is diabetic or not. Let me walk through you the code. So here, so this is the code. First, we imported the data science libraries, NumPy, Pandas, Scikit, Matplotlib, and Seaborn. Then we use scikit-learn's libraries to import the ML, logistic regression, random forest, SVC, which is for support vector machines, k-nearest neighbors, decision tree, gradient boosting. Then we have other performance analysis metrics, which is test train split. Then we have learning curve, confusion metrics, classification reports, and accuracy mean square error. We load the data set first using pandas data frames, and then this is just like the top 5 values header. We get the shape, the dimensions of the data, so it's like 9 columns and 768 records. So it's a pretty less data, but like this is what I got from the Kaggle. So I thought of instead of just putting random samples, just do whatever it is. So df-info gives you the informations like what the data is all about. Then we have few columns. We know the data type, not null conditions, and all. Describing the data, it's going to give you the count, mean, standard deviation, the minimum value, and the maximum value. If we were checking if there is any null values, no. So here in this particular data set, all the missing values were given 0, so which is not good. So we need to replace with a not a number, right? So NaN stands for not a number. And then we figured out uh, whatever 0, then we are going to give it a not a number. Then we figured out like how much samples were like that. Then we kind of got a count exactly. Then just to fill those gaps we use the mean value, and then we so this has been updated on df copy, and then we replace the data frame with df copy, and then we take uh, we do the plotting for uh, yeah, plotting. So we in this data set we could say close to 35% of people were diabetic. 65 on the other hand are non-diabetic. We just showed a pie chart and the bar graph. Then we so previously I told you, right, like it's close to 768 records. So now we have an actual count. So 500 people are non-diabetic and 268 are diabetic. Then we use the histogram density graph to get an overall idea of like how the density is for each parameters. And then we have the correlation heat map. So here it helps you to understand like how the parameters are correlated to each other. So higher the value, higher the correlation score. So I'll give you an example. So age and glucose level, no, age and pregnancies have a higher correlation level than 419. So yeah, insulin and glucose is also correlated to each other. And there are also cases where it's not correlated. So like blood pressure and diabetic's pedigree function is not that much of a correlated. It's like totally not dependent. Then we come into machine learning phase. Here we use logistic regression to kind of train the model first. Then we create the confusion metrics with the actual and predicted values. We plot the graph. We get a classification report for precision recall F1 score. We do this similarly for random forest. Get the thing. Here we can get a uh, higher accuracy. Then we have support vector machines. Then we have k-nearest neighbors. Then decision tree. So all the main popular ML models, and then XG gradient boosting, and then once all this thing is set, we got the cross validation mean and cross validated standard deviation for each and every models. So we could see a mean of cross validity accuracy score, and then we do hyperparameter tuning. Then we have this is like repeated stuff. Here we could see like how the accuracy has been dependent to each ML model. So here we could see the random forest has the highest accuracy compared to other other six. I mean six in total. So here um, we used the random forest for prediction. Here we could see we use the best fit random forest and used feature importance. And once we used feature importance, we could see like what feature is out of all the features, which feature is pretty important. So here we could see glucose level as being like the best feature or the important feature that we need to look into consideration while figuring out if a person is diabetic, to check or predict if a person is diabetic or not. Then we get with the best random forest, we are using the prediction to, these are like the custom values. So once we get these custom values, and then we can know like here RAS1 means the person who is diabetic. So, so like that, we'll be able to get it. So here with the custom values, we will be able to predict if a person is going to get diabetic or not. So this is a simple project. We used different ML algorithms and we trained each. We just test train split. We trained the model and figured out which one has the highest accuracy, and we got to know that random forest was the one which was giving us the highest accuracy. And with the random forest, we then kind of performed a feature importance metrics. Then also, and at last we used custom inputs to figure out. So if we get these features right, then we'll be able to predict. According to this particular model, we'll be able to predict if the person is going to get diabetic or not in the future. So the more data we get, the better. But the model should also not get to a inflection point or like um, the model should not get overfit. So we need to figure out the sweet spot and figure the things out. So that's it. Hope you got a glance of what the project is all about. Yeah, and this is how the project is being done. So thank you.